Some enterprise users are not ready to migrate wholesale to both container technology and the developer and operational workflow changes that come with OpenShift. For these customers, we offer migration tooling in the form of v2c, a VM image to container-based image conversion tool. With this tool, users can immediately gain access to a container-based image with familiar and certified content. This image can be used as is by running systemd inside of the container to launch services. It can also form the basis for additional image development. In this demo, we'll take a VM image, convert it to a container-based image using v2c, and then run a two-tier application with that image using systemd. Let's start by looking at a VM running a two-tier web application, WordPress. First, we'll start a virtual machine image using Vagrant. This represents our standard build and contains the packages needed for our sample application. Some of these packages come from core rel and others, such as WordPress, come from external sources. This is similar to what we might see in a typical deployment. Now we'll start the database and web server and navigate to the setup URL to show that our WordPress instance is functional. Now we'll convert the VM image to a container-based image using the Red Hat CDK and v2c tool. The v2c conversion tool is itself a container and can be used inside the Red Hat Container Development Kit, or CDK. The CDK is delivered as a Vagrant box in several formats. Here we're using Linux KVM running under libvirt. We've previously taken a snapshot of our standard build disk image and put it in the Vagrant working directory. When we launch the CDK Vagrant box, it automatically copies in these files. Now we'll pull in the Docker v2c image. The entry point to the v2c tool is a script that drives the conversion process. Here's how it's run. v2c uses virtualization inside of a container. This is a relatively new use case that produces several warnings. However, these are benign. The actual conversion is not affected. The output of v2c is a single file Docker image. Here's how we load it into our local Docker registry. We'll also give the image a simple tag to facilitate some of our work later. With no further modification, we can launch this container image interactively using bash and see that the content from the original VM is still available. And finally, we'll use a Docker file to create a derived image that runs our original application inside a container using systemd. Our converted base image requires a few small changes to allow systemd to run. We'll make these by building a derived image using the Docker file you see here. First, we need to provide the image with read-write volumes on run and temp. Next, we set the container environment variable. This lets systemd know that it's running under Docker. Next, we mask out a number of system-level services not needed in a container, and also enable the services for WordPress, and expose port 80 to allow web traffic. The run label launches Docker with additional options needed for systemd to function. And finally, the command entry point makes systemd the first process in the container. Now let's build and launch our systemd container. We'll launch the container using the atomic run command. This uses information in the run label shown earlier. We've left the console services on so we can actually see systemd starting, and we can log in to see MySQL and HTTPD running. And from a web browser, we can see that WordPress is functioning inside of the running container.